We are going to discuss the GeoGebra, how we can prove the Pythagoras theorem using GeoGebra. So first of all, we will take GeoGebra from application, education, GeoGebra. So it's opening now. So it's a window of GeoGebra. We have already discussed about the tools of GeoGebra. So here I will discuss the proof of Pythagoras in two ways. For that, first of all, I am taking this graphic view to some left side so we can view the more regions. First of all, I am going to draw a triangle. So from the polygon tool, I am taking the polygon. So in 3, I am starting. Then 4, I am going to draw a right angle triangle. Now it's 0 and then to 3, 0. So this is side A, it is side B, and side C. So the length of B it is 3, length of A it is a side A, length of side A it is 2, and we have to find the length of the side C. So for that, what we are going to do is, first of all, we will take a point that we will put in this input view. In the input, we will type in the bracket A plus B, comma A plus B. So here we can see that we got a point here that is D. So we have the triangle ABC and then another point D. Now I am going to take the center of this C and D. In order to prove the Pythagoras theorem, the center of C and D I am going to mark. For that, from the point tool, take the midpoint. Midpoint, taking the point C and the point D. So I got a midpoint here. Okay. So using this, I'm going to create another some triangles that is the mirror images of these triangles. How it is possible that I'm going to show. Listen, that is rotate about a point. Take that. That is rotate about this point. It is asking about the angle. Angle we require is 90 degree. Then okay. So here we got a triangle that is a mirror image of this. And again a rotated image of this, and again I am selecting this E and this triangle, so again it is 90 degree, so again I got it. So again this point and this triangle, and again it is 90 degree. Okay, so we got a square like this. So here we have the length of B as 3. So I'm going to mark it again, length of B as 3, that is distance or length. So here just so here we got B equal to 3, here we got A equal to 4. Suppose we had to find C. Okay, without using the Pythagoras theorem, that is hypotenuse square equal to base square plus altitude square, that we are going to show in another way. Now I'm going to put a point near to this square, that is suppose it is at 8. Okay, now Now what I'm going to do is I will place these two triangles, this one and this one together, and this one and this one together. That's the way I'm going to do. How I will do it, I'm going to show. Listen, for that, I'm taking translate by vector tool. Translate by vector. Take it. Now, suppose I'm going to move this one to there, this triangle. I selected it and just plotted a vector from here to here. So it has come to in this way. So I'm going to redo it. This one from this point to this point. That's also not possible. So these 2 points I plotted. So I'm taking from C to that point. Yes, it is the correct view. So try to remember that you have to place from C to this point. Now from this point to this point, I have to place this triangle. For that, selecting this and from here to this point, I got the another triangle. And again, I am going to plot these two triangles to this point, this way. In this region, I am going to plot the triangle. For that, first of all, I am selecting this one and from this point to this point. So I got a triangle there, and also this to there. It is from here. Yes. So we got all the triangles together. These two triangles together and these two triangles together. I plotted here. Okay. Now I'm going to discard these vectors. That is, first of all, I am selecting this one. Now right click it and show object, and hide object is in here. So I'm taking that. So it has gone. Again, the second one, right click it, show object. Again, the next one, right click it, show object. Next one, right click it, show object. Again, right click it, show object. Again, here also right click it and show object. So all those lines have gone, all those vectors have gone. So now I have placed these two triangles here and these two triangles here. Now I'm going to give the colors. Okay, so here I am going to give select the object and object properties. In the object properties, you can see the color. Suppose I am choosing this one, it has become red. We know that this is same as this one. This one also I am going to put the same color. Same color we plotted. Again, suppose this one having a similar color. I'm going to give again this one a similar color. Now this one I'm going to give some green color. Again this one. First of all, we will put this one, the green color. Again this one. I'm giving somewhat another color, that is this one. Again this object also with the same color. So coloring is over. So you can see the triangles. You can identify these triangles using these colors. So these two are together here and these two are together here. Again, we can see a portion around this E. That's also I am going to plot using the regular polygon for vertices. Here also I am going to plot a regular polygon here also. Here also I am going to plot a regular polygon. Now, here we can see that the side A is equal to 4 and B equal to 3. And what can be the side C? The answer it is, for that I am going to find the area of this square. To find the area of the square, I am going to the angle tool. Then from there I selected area. Here the area it is 25. Now I'm going to polygon 2. Here it is written as polygon 1, polygon 2 and polygon 3. Okay, the area of polygon 2 here it is 9. Polygon 3 here it is 16. We can see that 16 plus 9 is equal to 25. That is a square, that is 16, plus b square, that is 9, is equal to c square, that can be 25. So it's one of the way to prove the Pythagoras theorem. And another way that I am going to show, for that I am taking another file, new window. I am going to select that. That is simplest way to prove the Pythagoras theorem. For that, first of all, I am plotting a polygon from 3, 4, 0, and 3. Okay, for this, first of all, I am going to measure these two sides. These two sides, that is distance or length. Here, the length of B is equal to 3, length of A is equal to 4. Okay, now I am going to plot a regular polygons in all the three sides. That is square, regular squares. That is square B A, four sides. It's okay. And here also A C, four sides. Okay. Here also C. Oh no, it's in the right way. So we are going back from C to B. Okay, again four. So here also we have four vertices. To get the clear view, I'm moving it to the right side. Yes. Now I'm going to give different colors to each. Let it be of some color like green, and it be an another color that is light. No, its selection has not. Okay. Again, next one that is I'm selecting that is 275. Again, I'm selecting the next one. Let it be some blue color. Okay, here we have the three polygons, three squares. Okay, to find the uh, to prove the Pythagoras theorem, so I'm going to plot the areas of these squares. First of all, the area of this one it is 25. The area of this one it is 9, and the area of this one it is 16. When we add 16 plus 9, it is 25. So we can say that base square plus altitude square it is equal to the hypotenuse square. That's the proof of our Pythagoras theorem. I think it's clear to all. So try to remember the Pythagoras theorem in these two ways. There's another way also that we will share in the next class. Okay.